First thing, I'd like you guys to write 9.2 at the top of page 8. Okay, so go ahead and do that and box it. The title just printed weird on the previous page. Pause the video, make sure everybody has this done. Now, the objective, use graphs to show quadratic equations and find zeros of functions. We talked about zeros. Everybody box the word zeros. And they have a couple different names. We've called them solutions before. We've called them x-intercepts. We've called them zeros, and then we will also eventually call them roots. Okay, so all of those have the same process, similar meanings. What we're going to review first is solving a quadratic by factoring. So A is already in factored form. We have two sets of parentheses, x plus 1 in one, x minus 5 in the other, and it's equal to 0. B is not in factored form. This is standard form, so we'll have to factor him before we solve him. So let's go back to A. When we are solving after it's in factored form, we split the factors up. So x plus 1 is one factor, and we set him equal to 0. And we solve for x. Subtract 1 from both sides, and x equals -1. X minus 5 equals 0. We set him equal to 0. That was another factor. And now we just solve for x again by adding 5 to both sides. And so we get x equals 5. So those are our two solutions, aka zeros, aka x-intercepts, and roots. Okay? Part B, we have x squared plus 8x plus 15 equals 0. So on this guy, we need to factor him. He is not in factored form, he's in standard form. So we're looking for factors of 15 that add to 8, that add to positive 8. Okay, so I have 1 times 15, that gives me 16. I have 3 times 5, that added together is going to give me 8. So I'm going to use those ones. They're both positive, so I write x plus 3 times x plus 5 equals 0, stays the same. Now it's in factored form, so now we can solve it just like we did A. We split the factors, and we set each factor equal to 0. So x plus 3 equals 0, solve for x. Subtract 3 from both sides, and you get x equals -3. The other one is x plus 5 equals 0. Subtract 5 from both sides, and x equals -5. And again, these are our solutions, our x-intercepts, our roots, our zeros. Pause the video and make sure everybody has this. So looking at our example here, it says 2 real solutions. And they want us to solve x squared plus 2x equals 3 by graphing. Since they are asking me to solve, that means they want me to find the x-intercepts. Everybody write that. Because they want me to find intercepts, we learned a form in last chapter called the intercept form. And I'm going to write it. Let's write it off to the side here. Okay, intercept. And we'll just have to write it once. Oops. There we go. Intercept form. Where we can write it as f of x equals x minus p, x minus q. Okay, we learned this last chapter. And so I know in the directions above this, they said you could use standard form and find the axis of symmetry and then find the x-intercepts. But if I already know they want the x-intercepts, why not put it into that intercept form? I can find my intercepts a little bit faster with less steps and kind of things that I can make minor errors on. So let's go ahead and we're going to change it into intercept form, which means first that I can't have this 3 on a different side of the equal sign. I always need everything all on one side, and I need it equal to 0, kind of like how our number 2 is, okay? That guy's set up for me. This one's not. So all I have to do, though, we've learned this since chapter 1, is just subtract 3 from both sides, and it'll move that 3 over. So now we have x squared plus 2x minus 3 equals 0. This is our function. So 0 is kind of acting like our output right now, our f of x, which is fine. I can leave it as 0, I don't mind. What I want to change is that instead of having it in standard form like this, I want it in intercept form, which is essentially factored form. So that's why we practice factoring above, and we reviewed that first, because that's what we're going to have to do for a lot of these that are in standard form. We're going to factor them. So I'm looking for factors of -3 that add to 2. Well, the only two factors of -3 are going to be either -3 and +1, or +3 and -1, okay? So I'll write those down. It's either this times a +1 or this times a negative. To decide, remember we look here. This middle one has to match the bigger factor. Well, 3 is bigger, so we need to make sure that the 3 is getting the positive. Plus, if I added -3 and +1, that would have given me a -2, and I don't need that. I need a +2. So there we go. This guy is now in intercept form. Yay. Okay. We have x plus 3 times x minus 1. 2 sets of parentheses. We have x's. No powers of 2 anymore. Now we're in intercept form. And just like we did above, how we set each factor equal to 0 and we solved, we could do that too. We could also just remember that, hey, we did this last chapter. Inside opposite, okay, so inside I'm going to have the points negative, let me write that a little bit better, -3, 0, and then this -1 here becomes a +1, 0. We learned this last chapter, so this is just reviewing. So that means that these are points on my graph. So I'm going to go to my graph, and I'm going to go -3, 0, which is right there, and +1, 0. Now that I have 2 points, I know my x-intercepts, all right? Now, they do want me to finish graphing. If they didn't, I could just use these as my solutions and be done. But I need to finish my graphing. So we'll continue, find a vertex, find our axis of symmetry, all right? So each form, last chapter, had an axis of symmetry. Our intercept form had an AOS, we abbreviated it as, right? And that was x equals p plus q divided by 2. That was our formula, okay? These are 2 that we definitely need to have either memorized or written down. So make sure you're writing what I write. These numbers here, those are our p's and q's. So -3 is our p, 1 is our q. So if I want to find my AOS, all I have to do is add those two numbers together, -3 plus 1, and then divide that answer by 2. Well, -3 plus 1 is -2, and that divided by 2 is simply -1. So that's my axis of symmetry. I go to -1, and I draw my vertical line for my AOS. And I'll label it down below since AOS x equals -1, okay? So now that I have that, I just need my vertex, and then I can connect my points, and I'm done. My vertex is found by taking my axis of symmetry, okay, we found it to be x was equal to -1, and just plugging it into our original function. So anywhere I see an x, I'm going to put parentheses. So I have x squared plus 2x minus 3. And inside, I'm going to put my, it went to an eraser, sorry. I'm going to put my -1 because that's what we found was our x. Okay, if this was -10, I would have plugged in -10. Once I do that, I can type that straight into my calculator, or I can use my PEMDAS rules and do it by hand. Whichever one you do, you will get the same answer. So -1 squared is 1. 2 times -1 is -2, minus 3. So we have -4 here for our output, our value. That means our vertex is the x value that we found at -1, comma, -4. And so we get to plug that in on our graph. So I go -1, and then I go down -4, and I'm going to put a point right there on the graph. Now that I have 3 points, I get to connect them with a U shape, not a V, a U shape. If you draw a V, that's an absolute value. Quadratics are U's. And so if they want me to solve for by graphing, I can write, I'm going to draw an arrow. This is a solution. Okay, solution here is x equals 1. So that's one solution. And then the other solution is here. X equals -3. Okay, so we have our 2 solutions, and it's because our graph is touching in 2 spots on our x-axis. So those both numbers are my solutions, -3, +1. Let's look at this next guy. Oh, I'm going to skip this next guy because, sorry, this is what happened, and this is why I made a new video. This guy is kind of fallen off, okay? So it's going to be a slightly shorter lesson today. So we're going to just cross this guy out. Okay, turn the page. Here we go. Zoom in here. So we have x squared plus x equals 12. Again, very similar to what we had to do with our 3 on that first example. We're going to move our 12 to the side with my x squared and my x. Now that we have it all on one side, now I can put it into intercept form. So I'm looking for factors of -12 that add to a 1. Remember, there's a 1 here in front of the x. So factors of -12, right? And we have to add to 1. Well, factors of -12, we have 1 and 12, 2 and 6, 3 and 4. If it's negative, we need one of these guys to be negative. Right now, it's giving me positive, so I need to change one negative. I look to the middle. The middle is positive. That means all my bigger factors are going to be positive, making my 1, 2, and 3 having to be negative. So then I just check which one adds to 1. Well, that guy doesn't, that guy doesn't, that guy does. Okay, -3 plus 4 gives me 1. So those are my factors for my factored form, aka intercept form. So I have x minus 3 times x plus 4 equals 0. This gives me my intercepts, inside, opposite. So -3 is the point 30, and +4 is the point -40. So I'm going to go to my graph. Okay, I don't have anything numbered, so I'm just going to make sure that I'm counting by ones. So I'm going to go center, 1, 2, 3, put a point on 30, and then put a point on 1, 2, 3, -4. Okay, again, they want me to graph it, so I do have to finish it. Okay, so we're going to do the same thing. We're going to find our AOS, which is just taking our P plus our Q, which is 3 plus -4 in this case, and dividing it by 2. 3 plus -4 is -1, divided by 2 is still -0.5. If you wanted to write -0.5, that's fine. That is our vertical line, AOS, x equals -0.5. And that cuts our parabola perfectly in 2. So these 2 points should be the same distance away. So this is 1, 2, 3.5. This is 1, 2, 3.5. So we're good there. Now we just plug -0.5 into our original, okay, before we factored it, and we'll find our y for our vertex. Vertex is a point, so we already have the -0.5. So now we're just plugging in to find the y value. So I have x squared plus x minus 12, And inside those parentheses, I'm putting my negative 0.5. And again, you can do this in your head. You can do it using a calculator. Remember, parentheses matter, powers of 2 matter, so make sure we're typing it in correctly. So I got negative 11.25 for this guy. So that is going to be my vertex. So I go over here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm gonna have to extend my graph just slightly. 11, 12. So negative 11.25 is just a little bit underneath my negative 11. And I can now connect those with a U. And now it's graphed, okay? And again, my solutions are always my x-intercept points. So one solution was x is equal to 3. The other solution was x is equal to negative 4, okay? This is just the graph showing the solutions. This guy, we're gonna show one where it's one real solution. The graph misprinted, but that's okay. We'll make it work, okay? So on the next page, if we turn, this guy is going to be a 1 solution. So far all the other ones were 2 solutions because they touched twice. This is called a 1 solution because it's only going to touch 1 time. So we still do the same process. We need to move that negative 16 over, so now we get to add 16 to both sides. And we have x squared minus 8x plus 16 equals 0. Get it into intercept form, so factors of 16 that are going to add to negative 8. Well, the only way to multiply to a positive but add to a negative is to have 2 negatives. And the only factor that does that is negative 4 times negative 4. That will give us a positive 16 when we multiply and a negative 8 when we add them together. So since they are exactly the same, you'll notice we have the same exact point for our x-intercept. Means there's only going to be 1 point. And I know there's no graph here, so we're going to sketch. Okay, this was our y, this is our x, and since this is 4, we'll go 1, 2, 3, 4. Okay, and then put a dot. And do your best to separate those intervals as evenly as possible. Now, again, since this is only 1 point, I only have 1 point to put. We had this last chapter too on one of our homeworks. So I need some more points, right? I need to be able to find my axis of symmetry or my vertex or my y-intercept. Well, when this is exactly the same, this guy is actually the vertex. And so our vertex is that 4, 0, okay? Which means our axis of symmetry goes straight through it. So everybody draw a straight vertical line and write AOS, okay? Now I'm gonna go back a little bit because it was originally in standard form. Now, because these guys are the same, I'm glad I have my standard form written because I do have a secret point right here. Anytime you have standard form, ax squared plus bx plus c, our c value is always our y-intercept. So that gives me another point I can graph. My c value in this case is my 16. Remember, c is just the number at the very end. So I'm going to go up to 16, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I'm going to extend mine a little bit. This is why I always use pencil. 15, 16. Okay, so that is my y-intercept. My vertex never gets copied. We talked about this last chapter. My y-intercept, though, can be copied on the other side. Now, It's 1, 2, 3, 4 points away from my axis of symmetry. So the copied point will have to be 1, 2, 3, 4 points away as well at the same height. Now I have enough points to connect and draw my parabola, okay? This is what a one solution looks like. It will only touch one spot. So the solution here is the only x-intercept, which is 4. This guy here, we have x squared plus 4 equals negative 4x. So again, just making sure we have them all on one side. So add 4x, x squared plus 4x plus 4 equals 0. Get it into factored form or intercept form. So we can do positive 2 and positive 2, right? That multiplies, that multiplies to 4, positive 4, and adds to 4. And again, since I am seeing both of these guys are exactly the same, I'm seeing that I'm going to get just one x-intercept, which tells me that that is also going to be my vertex. And so I'm going to make a point on negative 2, 0. Since it's my vertex, that tells me that my axis of symmetry is going straight through it, and that I will need to use the standard form and look at my C value. My C value is positive 4, okay? That's this guy right here. This is my C. So that is my y-intercept. I go to positive 4 on my y-axis. I put a point. That guy is 1, 2 away from the axis of symmetry, so now I get to match a point on the other side. 2 away. I connect, and there's my parabola. I have one solution because it's only touching in one spot. My solution is x equals negative 2. Again, misprint on the bottom, but we'll just move that real solution to the top here, okay? Real solutions, or sorry, no real solution. Okay, we have done ones where they were 2 solutions and they touched twice. We have done it where there was 1 solution and it touched once. Now we have no real solution, and so it's going to not touch at all right? I'm going to just do number 7 because it's got a nice graph here. So let's go ahead and just pop down to number 7. So this guy's set up for us, x squared plus x plus 2. Now, we have been able to do intercept form, right? Finding factors of 2 that add to, in this case, 1, right? We need to add to 1. Well, factors of 2 include 2 times 1, or 1 times 2, whichever one you want to say, 1 times 2. I can make them both positive, I can make them both negative, but no matter what, they're going to add to 3 or to negative 3. They are never, ever going to add to a positive 1 because I need a positive 2. So it's not like I could do 1 negative and 1 positive in this case, because then my multiplication would be off. So when you have one that is what we call unfactorable, okay, that means I cannot write this in intercept form. So I'm just going to go ahead and graph it in standard form, which is fine. We have done that before as well, okay? Axis of symmetry for standard form is a different formula. We learned this last chapter. We learned it that it was opposite B divided by 2A. So if you need to write that guy down, actually everybody should write that guy down. And then we're going to plug it in and find our axis of symmetry first. So AOS for this guy is x equals, opposite B would be negative 1, divided by 2 times A would be also 1. Remember, we have our A value here, which when it's not visible, it's 1. Our B value here, and this guy is our C value. So I plug it in, -1/2 is just -0.5. So we have our axis of symmetry, so we're gonna do our vertical line at -0.5. -0.5, and start drawing your vertical line straight up and down on your graph, AOS. And just like before, once we have our axis of symmetry, we take that x value and we're gonna plug it into our original to find the rest of our vertex. Remember, vertex is always that axis of symmetry, the x value, and then after we plug it in, we'll find our y value. So we have x squared plus x plus 2. Inside, we're putting that -0.5. -0.5. We're going to calculate that either by hand or in our calculator, and let's get our answer. Okay, so this one I got was 1.75. 1.75. So now I'm going to go to my vertex. Okay, I have -0.5 here, and then I go positive 1.75. So I'm almost at my 2. Okay, that is my vertex. Notice it's above, it's floating above. So next I need to see, well, where is my y-intercept? Remember, our C is always our y-intercept. So if I look at my original, my C in this case is 2. So on my y-axis, we're going to 2. And we're putting a point. A matching point on the other side. So it makes it for a very small parabola here, but that's okay. We'll make it work. I'm going to zoom out just slightly here. There we go. I can connect these guys now. They're going up forever. And so they're going up forever. They will never come back down. So the fact that my parabola is floating in the air, this is what makes it have no real solutions. And so if I get a graph where my parabola is just floating like this, never crossing this, okay? Even if I extended my lines completely all the way up, I can keep going all the way up. They are never ever coming back down and crossing this. That is a no real solutions case, okay? If for some reason I had a negative and it flipped it, then it would touch and I'd be fine and I could do it just like I did my other examples. But it doesn't, so I can't. That's it for today. On the next page, I'd like you guys to go just to the next. Now, it's homework time. And we're going to title this 9.3. That will prepare for next week. And